First step in determining flows of a two-dimensional dynamical system, let's look very close to a fixed point and look at a linearized analysis of the flow near such a fixed point. This is the first step in then trying to patch together local flows to get the global flow. So we started with our equations of motion. X dot is equal to f of xy, y dot is equal to g of xy. And the idea for linearized analysis is that let's write x is equal to its fixed point value, x star, plus a small deviation, and similarly for y equals y star plus epsilon y. And then we plug these into the equations of motion. So on the left-hand side, when we compute x star dot is 0, and so we just have epsilon x dot. But on the right-hand side, we perform a Taylor series expansion of f about x star and y star. And as long as nature is not cruel to us and there are linear terms in the expansion, then this analysis goes through. And so what we get is epsilon x df by dx plus epsilon y df by dy. And similarly for epsilon y dot, we'll have epsilon x dg by dx plus epsilon y dg by dy. And so let's write this in matrix form just for compactness. I'll write this as epsilon x dot, epsilon y dot as a column vector, and I'll write it as then in matrix form. And for notational simplicity, let me write, instead of df by dx, let's write that as f sub x, and then f sub y, g sub x, g sub y, multiplying epsilon x, epsilon y, which I can write as a, b, c, d, arbitrary coefficients, epsilon x, epsilon y. Or if we want to write this in more compact matrix form, I can think of this as the vector epsilon dot is equal to some matrix capital A, epsilon. So let's now look for the nullines in this linearized analysis. So the nullines, epsilon x dot, which according to this matrix formulation is A epsilon x plus B epsilon y equals 0. So that's a nullline where epsilon x does not change. And similarly, epsilon y dot is equal to C epsilon x plus D epsilon y equals 0. So these are the nullines. And notice that in the linearized analysis, these nullines are straight lines, which makes their analysis rather simple. So now we're in a position to outline how we determine the local flow in the linearized analysis. First of all, one is that the intersection of nullines defines the fixed point. So we find the fixed point by this intersection of the nullines. Second point is that when we have two intersecting lines, there will be four sort of pie-shaped segments, where in each of these pie-shaped segments we can determine the flow. So determine the flow, each of four segments. And finally, we then can infer local flow. This is the program that will follow in the examples that I'm going to show.